Good day, my highly esteemed viewers. You are welcome back to class. You know, my name is Israel. Today, we are going to talk about another topic within the periodic table. It is called families of elements. As you can see on the board, periodic table families of elements. When we say families of elements, we are talking about elements that have the same number of electrons in their outermost shell, meaning they belong to the same group. Elements that belong to the same group are said to belong to the same family. And remember, before they can belong to the same group, they must have the same number of electrons in their outermost shell or the same number of valence electrons. As a result of that, they also share similar properties. Now, there are so many groups. You have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group O, or group 0, or group 8. Many textbooks call it different names. So all of them are correct. But I always prefer to call it group 0 or group O because of helium. So, but it's still correct. So if you look at the groups, in our discussion, we are going to take it bit by bit. So we are going to share the video into different parts. So today we are going to have a look at the first 3 groups. So you have group 1. Elements in group 1, they are known as alkali metals. That is, those are the elements that are, because they dissolve in water to form alkali solution and liberate hydrogen gas. Now, all group 1 elements, based on their properties, all group 1 elements, they are univalent. That is, they have a valency of 1. They are called univalent elements. So, example of such group, you have sodium. These are the symbols. You have, first of all, you have lithium. You have sodium. You have potassium, based on the first 20 elements. So all these ones are group 1 element because they have 1 electron in the outermost shell. Remember we said they are univalent. Again, all group 1 elements, they release 1 electron in their outermost shell. For example, sodium, you have 11 as the atomic number, 281. So they give out 1 electron. They give out 1 electron. Potassium, all of them give out 1 electron. So they form very strong reducing agents. Remember, they are giving out electron. So they form reducing agent because their own element, they increase in oxidation number. So they form strong reducing agents. Then again, they are highly electropositive in nature. All these groups, they are highly electropositive in nature. Good. Meaning that they can form electrovalent compounds because they form charges. By forming positive charge, they must have given out electron. So they form strong electrovalent compound. So those are group 1. Remember, we have just said 3. With the first one, we said they are univalent, valency of 1. Secondly, we said they are good reducing agents because they give out electrons. Third one, we said they are strong electrovalent. They form strong electrovalent compounds. Then group 2. Again, remember we said they dissolve in water to form alkaline solution. For example, sodium plus H2O, NaOH plus H2. Put to here. 2NaOH plus H2. They liberate hydrogen gas. So these are group 1 elements. Then for group 2 elements, let's put it here. Group 2. Example, you have beryllium, you have magnesium, you have calcium for the first 20 elements. So all these ones are group 2 elements. So group 2 elements, they give out 2 electrons. So meaning they are divalent. For example, calcium, can even use magnesium. Calcium, which is 20, 2882. They give out this electron to form Ca2 plus 2 electron. So they are divalent. Just like group 1, they give out these 2 electrons. So they are strong reducing agent also. And apart from that, they are also known as strong electrovalent compound. They form strong electrovalent compound because they give out electrons to form a positive charge. So something must take it. So they combine in their compounds, they form strong electrovalent compound. Remember, group 2 are known as alkaline metals. Alkaline earth metals. They also dissolve in water. Many of their compounds, some of their compounds dissolve in water to liberate hydrogen gas also and form alkaline solution. That is that. For example, now we say some of their compounds, like the first one, beryllium, does not dissolve in water, does not react with water, whether steam or cold water. But magnesium reacts with water in the form of steam. Let's see how it goes. React with water in form of steam. This is magnesium plus H2O to give you MgO plus H2. So they react with water in the form of steam and liberate hydrogen gas. Whereas the first element, which is beryllium, among the group, first element in the group, which is beryllium, does not react with cold water or steam. Then for calcium, calcium reacts with cold water to form calcium hydroxide and liberate hydrogen. So these are some of the elements that form group 2. So that is that on group 2. Remember, they have strong electrovalent compound because they give out electrons. Something else must take it. So then you have the last but not the least we are going to talk about. You have group 3 elements. Group 3 elements, they are group 3. They are trivalent elements because they have a valency of 3. Example include boron, aluminium, boron and aluminium. I don't little boron and aluminium. So these ones are known as group 3 elements because they have 3 electrons in the outermost shell and they easily give out the 3 electrons. For example, aluminium 13, 2, 8, 3. Give out electrons to give you Al3 plus 3 electron. So that is that. They are trivalent. They are also good reducing agent because they give out electron, making them good reducing agent. And they also form electrovalent compound because any element combining with it must take 3 electrons from it. If there's no 3 electrons, the reaction will not occur. So they take 3 electrons from it, leaving it with a positive charge of 3. So they form strong electrovalent compound. Then aluminium on its own does not react with cold water. They only react with steam to liberate hydrogen gas. But the oxide they form, which is aluminium oxide, remember, Al2O3, is usually amphoteric. When we say amphoteric, it means it has the properties of both acid, can behave as an acid, can also behave as a base when the conditions are changed. So those are the ones we are going to take today. Remember, we said we are going to divide into B's. Today we have had group 1, group 2, group 3. Study properly and try to jot down things. You will understand it. It's not tedious. Next class we'll discuss further one, starting from group 4, silicon and germanium. We'll continue again as long as time will permit. God bless you. Please kindly share. Thank you.